Should be rolling. What is today? Today is the first, May 1st. There we go, May 1st. Nitty-gritty logarithm. So the very basics of how to do a logarithm. Okay? Up until this point, in your math, if you had just me, you haven't learned how to solve for exponents. Right? So we haven't really talked about how to do that, so that's what we're going to do today. We're going to talk about how to solve for exponents to be able to solve any of this problem. Wait, keep going. Keep going. All right. So let's take a look at this one right here. Okay. So does anybody know how you would solve that? Get an idea how to do that? Something to the fifth power equals 33. Something to the fifth power equals 32. You might know. Because 2 to the fifth is 32. But what to the fifth power is 33? That's a hard problem, right? So what we do in this case is not really a logarithm. This one is just going to be what we call, you know, like if I had something squared and I wanted to undo it, I do what? So what's the opposite? Square root, exactly. So the opposite of square, something being squared, is square root. Now, you didn't know this, but the whole time you've always been doing square roots, there's actually an invisible 2 there. We don't write it. It's assumed that if there's nothing there, there's really a 2 there. And that's why those 2's kind of cancel out with each other. Okay? So, vice versa. Just like if it was squared, let's say it was cubed, right? If I had something cubed and I wanted to undo a cube, I would do what we call a cube root, right? So it kind of looks like this, but there's a little 3 there. Okay? And 4, 5, 6, it goes up like it always does.
Good morning. At this time, Miss Grimm's American Government.
Alright, we're back now. Okay, so you undo a square by a square root, you undo a cube by a cube root, you undo a fifth, something to the fifth power by a fifth root. Exactly. Right? So it's not that hard. So that's how you undo things. So let's think about this problem we have in front of us here. We've got x to the fifth equals 33. So if you want to undo x to the fifth, we are going to fifth rooting on both sides. It kind of looks like that. It has a little 5 there. Right? So what's going to happen is these 5's are going to cancel out with each other and just leave it as an x, which is what we want. And then so x would be equal to the fifth root of 33. Now, how do we do that? Right? How do we do that? Because that's not a button that you're used to. So that's why I got the calculator pulled up here so we can kind of see how that works. So what you're going to do is you're going to turn the calculator on, obviously. Hit the on button. Okay? And then you're going to hit, there's a key that's right here. Okay? Oh my gosh.
Excuse the interruption at this time. All steps to speed.
Front porch. Gotta go to the front porch. Okay, so there's this key right here, and if you look at it, in the blue, it has a little X with a square root like that. You know what I'm saying? See that on your calculator? That's how you're gonna do this. So what you're gonna do when you enter in this, when we're trying to do this entry in the calculator, you're gonna hit the 5 key first. So you're gonna hit the 5 key first, okay? Because that's gonna tell you you want a fifth root. Okay, so you hit the 5 key first. Then you're going to hit second. Then you're going to hit this button. Okay, so second, that button. So you're going to go 1, 2, 3. Okay, and then you're going to type in the 33. So then it'll be 33. Okay, so 33. Hit enter. When you do that, so you're going to go 5. That's the first key. Your second key is this. Oh, I'm sorry. Your second key is the second. Right, and then your third key is that button, and then your fourth key is 33. All right, and then when you type that in, you should get 2.0123 and some change. Okay, did you get the same thing? All right, so what does that mean? That means that x is equal to 2.0123. So that means if you take that number and you raise it to the fifth power, you'll get there. Does that make sense? So you're just undoing it with it's something different than a square root. It's what we call a fifth root. So that's how that one works. Why don't you go ahead and try, how do you think we would do this one? Let's just talk about how we will do this one, and then I'll let you do the last one by yourself. So how will we do this one in red right here? If it's something to the 7th power, we undo the 7th by doing like the 7th root, right? So you're going to do this of this. You're going to do that on the other side as well. 2983. And then what's going to happen is the 7s cancel out. Those are gone. You get an X. And then this will go in your calculator. See if you can figure that out. I'm going to pause it. Okay, so if you tried that out and you typed it in your calculator, right, you would have hit in keys here, in order, you would have gone like this. You would have hit the 7 button first, the 2nd, then this button, and then you would have typed in 2983. And then that would have put out, if I did it right, 3.14 if you round. Is that what you guys got? Okay, so that means if you take this number, 3.14, and you raise it to the 7th power, you should get 2,983. That's not very good, right? Okay, you try the last problem by yourself. See if you can figure that out. Pause the video and we'll see on the next one. Okay, so that was the easy stuff. So let's try the harder problems. These harder problems are where there's an exponent, or there's a variable in the exponent spot. So the last set of problems had an X on the bottom. Now your X is on the top. So how do we handle that? That's where it gets a little bit tricky. And that's where it's going to require a little bit of a technique in which we don't have yet. Okay? You don't know how to solve this. I haven't showed you how to solve this. Okay? You haven't come across this in your math. At least you might have, but most of us haven't. Okay? But this is how we handle it. Okay? So on the bottom, the big idea here, right? Here's the big idea, is that if a logarithm is a way of solving and bringing that exponent down so you can access it. So the big idea here is this. So let's just say you have the variables x raised to the y equals z. Okay? That's going to convert. That's going to be the same thing, right? So that is going to translate to log with an x on the bottom, a z here, and a y. And I know you don't know what that format is yet. I'm going to show you. It's not that hard, but that's the relationship. Okay, and this is what we're going to need for our calculator. So I'll write for calculator is log of z divided by log of x equals y. So this is only for our calculator, but this is the big idea, okay? So I'll show you how we run through it. I know it looks complicated, you haven't seen it before, but it's not really that big of a deal. Hey, how's it going? Okay, so let's see if we can apply this. This is just literally just recognizing places and structures, all right? So if you were looking at these problems over here, all right, let's take this problem right here. 4 raised to the x equals 64. Now, which one does that relate to? This red equation or this green equation? Which one does it look similar to? The red one. It's the same format as the red, right? The 4 is really the what in our? It's the x, right? And the y is really our. Well, that's kind of confusing. The y is our x, right? And then the 64 is really like our z. Does that make sense? Alright, so let's see if we can translate that to the green. Because if you can do that, then you can start to solve it. Alright, so we're going to translate this to a logarithm. So it's going to go log. Alright, now what's going to go on the bottom? Let's see. The x is right there, so the x goes on the bottom. But what's our x in this format? The 4. Exactly. The 4 is our x. So the 4 is going to go low. Okay? The 4 is going to go low. The z, what is a z in this structure right here? 64, exactly. So the z goes right there next to the x. So this is going to be 64, right? And then this is our y value. But what's our y value in this structure? X. Exactly. So this is x. Does that make sense? See how we just set it up? Okay, we're ready to solve this thing. So now what you did is you isolated the variable, which is what we wanted to do, and now you're done. If you had a fancy calculator, you could type it directly in there, but we don't have the fancy calculators. We got the crappy calculator. So what we need to do is do this. Okay? We need to do that. So let's look at how that's set up. Right? It says log of z over log of x. This is the way I always remember it. I go like this. Okay. That means that the guy that's in the basement, because this guy is he's a subscript, he's below, he goes down. The guy that's on the regular line, he goes up. So it's going to go like this. Log of 64 divided by log of 4. See how I did that? And then that can go directly in your calculator. And then we'll have our answer. So let me show you how you type that in the calculator. Let me grab the calculator from the other slide. So I show you the strokes. Okay, so key strokes, that in the calculator. This is how you're going to do it. You're going to go, okay, so what you're going to do, the log button is right below the second, exactly. So the log button is right here, okay? And you don't need to hit second or anything, so we're just going to type in, your keys are going to go log, you're going to hit the log key, so that's 1, and then you're going to hit 64, so 64, so log of 64, and then you're going to close off the parenthesis because it opens up a parenthesis. So close that parenthesis off. You hit divide sign, so here comes the divide sign, and then you're going to hit log, which is this key again, right? And then you're going to hit 4, and then you're going to close off the parenthesis again. And that will be it. And if you hit enter, you get 3. Did you guys get 3? Yeah. Okay, so that's not that hard. So let's see if that makes sense. Now, there's an easy way of checking this. Is 4 raised to the 3 power 64? Well, let's see. 4 times 4 is 16. Times 4, 64. It works. Okay? So it's as easy as that. It's not that bad, right? That's not that bad. And that's really like a quarter's worth of algebra 2. Kind of condensed for you. Let's try another one, because I know that you're not going to get it on the first try. So let's try this next one right here and see if we can figure it out, okay? We're going to try this guy right here. All right, so look at the structure, how it's set up, and then we're going to adjust into this format right here. This is the format we're going to try to relate it to right there, okay? All right, so this 16 would be my what in this structure? It'd be my x. And the x would really be my y. And the 1024 would be my z. Does that make sense? Okay. So we're going to write that in the green form. We're going to write it in this form right here. Okay? That's the form we're going to try to write it in. So let's try that. So it's going to go log. All right? Now, the x we said was the 16, and that goes low. So 16 is going to go low. And then the z we said was the 1024, so that's going to go high. So that's 1024. And that will be equals my y value in the structure, which in our example is the variable x. That's it. Okay? So once you get familiar with switching between the two forms, it's pretty easy. Okay? So now how are you going to type this in the calculator? This is done. And if you had those fancy TI Inspires that we had last year, you can type that directly in and you'd be done. But our calculators won't let us do it that way. So we're going to use this form right here, this change of base formula. So how does that going to go? It's going to be a log of something on the top divided by a log of something on the bottom. What's going to go on the top? What's going to go on the bottom? Let's see if we know this. Yep, 1024 goes on the top because it's on the top, and this guy's in the basement, so he's going in the basement. That's it. So you just type that in your calculator, just like we did before. So you're going to hit the log button, put 1024 in, close off the parenthesis, divided by the log button again of 16, close off the parenthesis. I get 2.5. So you can check your work. 16 raised to the 2.5, is that really going to be it? Well, I can try that. 16 raised to the 2.5. Yep, works perfectly. So we're set to go. That's it. It's easy as that, right? That's not too bad, right? why don't you try this last problem by yourself, okay? And then we'll try some slightly harder problems. Try that problem. Get these guys back in. All right, welcome back. You should have, if you've done this right, you should have got x equals 4.799 and some change. So that's about what it is. So there you go. Okay, so let's try a slightly harder problem before we actually turn to application. Like I was just telling these guys, this is for solving for time on any kind of investment problem, any kind of exponent or anything in the financial world in which you're solving for time. You want to know how much time that my car is going to be worth $500. You need to know how to do this kind of skill to be able to do that kind of problem. So that's what we're doing. All right, so these ones you're working backwards. I think these are the last problems, right? All right, these are the last problems. These ones you're working backwards. So it's a hodgepodge of a bunch of different mix of things, but you're still going to use these same main ideas. These are still the big ideas that we're using, okay? But you have to recognize structure and move it backwards, okay? So let's see if we can figure this out. I'm going to rewrite this one nice and big. It's too small. So here we go. I'm going to do the red one. So log base 2 of 53 equals x. Okay, so what I want you to do is take a look at this structure and say, how does it relate to my variables here, right? Well, you can kind of see it, right? The 2 is really like my what? My x, right? And my 53 is kind of like my z. And my x is really kind of like my y. I know that the letters are kind of overlapping, but that's the structure of it. So it keeps that structure. So what we're going to do is we're going to move over here, right? So the y we know is going to go high. We know that the z is going to go over here, and the x is going to go there. So let's switch it to that form, and I think you're going to be done. So let's see if we can do that. All right. So here we go. So we're going to move back to the other form. So it says my x, or my green guy, is going to stay low, so that's 2. And then it says my blue guy is going to go high, so that's my x. And then, yeah, that's my x. And then my z is the yellow guy, which is 53. So that's how you switch between the two. But you know what I just realized? Did we have to switch it? Was this one ready to go? I just made work a little bit harder on us there. It was ready to go. I didn't need to switch it. You're going to have to switch on some of these other problems, but this one, you didn't need to switch it. It was ready to go. Look, the x is isolated. That's what we want by itself anyway. So all we really have to do is take this portion of the problem, this portion right here, and drop it in the calculator. Do we know how to drop that in the calculator the right way? Yeah, what's it going to be? It's going to be log on the top and a log on the bottom. Which one's going to get the top? Which one's going to get the bottom? 53 goes on the top, 2 goes on the bottom. So that can be just typed in. I did a little extra work there. I didn't need to do that. We will have to do that on the next problem or two. So let's figure out what this is, and we'll be ready to go. So log on the top, log on the bottom. We'll do a little bit of work there. Let's see. So log 53, close it off, divided by the log of 2, and you get 5.7. 5.727, something like that. Okay. So there you go. So that's your answer. That was actually pretty easy, right? Now the next problem is not quite that way. It's a little bit different. That's where you're going to have to really recognize that structure. So we'll try that the way I just tried to set up the first part of that. Hopefully that's not confusing if you're watching this video. All right. Okay, so that's the first one. Let's try the second one. I'll do it in green down here. So log x goes to the bottom, 903 here, 5 over there. So let's color match here. So yellow, or my green is going to be this guy, right? My yellow is going to be this guy, and my blue is going to be this guy, and I'm relating that back to the structure over here. Okay. So let's switch it back the other way, because you can't solve it this way. There's no way of solving it this way. You have to move it out. If you have an exponent, if you have an x here or here, you got to move it back. You can't do anything with it. So moving it back, the green is going to go low, so x is going to go low. Yellow or blue is going to go high, so that's 5. And then yellow is going to go on the other side of the equal sign, so that's going to be 903. Okay, So now you know how to solve this, because this is just like the first 3 problems I gave you. What do you do to solve that? You just do what? If it's something to the 5th power, you want to undo the 5th, you do what? 5th root. Yeah, exactly. So we're going to go the 5th root of this and 5th root of this. So this is like the first 3 problems I gave you on the sheet. So these, if you take the 5th root of both sides, we know these cancel out. So you get x equals whatever the 5th root of 903 is. I don't know what that is. It's probably not a pretty number. Let's see. So hit the 5 button first, then second, and then the caret button. So you get the square root symbol. And then 903, and then enter. You get 3.9001. Or, oh, yeah, whatever. Okay, you get that. Okay, so there you go, you're done. Does that make sense? It's not hard, right? And really, that's the bulk of the only reason you need to know how to do logarithms. If you know how to do just that, you can solve a plethora of problems. So go ahead and try this one, and we'll come back with some answers here today. Well, go ahead and try the rest of them. I think you actually saw the rest of them. I'll pause it. We'll try the rest. We'll write the answers, and then we'll move on. Get this going here. All right, so if you're coming back, there's your answers up on the board. We kind of highlighted the colors, and we got some solutions there for you. And we think they're all right. They look pretty good. So hopefully you did good with that. You can pause that video and write those down or kind of follow through if you need to. But we'll have a quiz on this probably not next week, but following week, or maybe late next week, something around there. We're going to do car depreciation, logarithms, and mortgages all wrapped up together because they're all similar ideas. We'll have a quiz over that, all 3 concepts. So this paper that we just got done doing, I would strongly hold on to, okay, because I based the quiz off this paper. So if you have this paper, you're going to be smart. If you don't, all right. So why did we do all this junk, right? So we did all this junk to solve problems like, not that one, this. Yes, this. This is why we learn that concept, okay? So this is on your car depreciation problem, and we might be bouncing around a little bit, but I want to show you why we learned it, okay? This is why you. Okay, so here we go. So we're going to try this problem together. So that way you have an idea of what I'm talking about, and then we'll kind of go from there. All right. So you got Leah and Josh. They bought a used car for $20,000. Expensive used car. Okay, so sorry about that. Josh and Leah, they bought a car for $20,000. The car, when the car was new, it was sold for $24,000. If we know the rate of depreciation is 8%, how old is the car? So this is the base model for this equation. Y equals A times 1 minus R to the T. And then why it's minus is because this car depreciates. It doesn't grow. All right. Now, variables we know. Remember, this is used. This is new. This is rate. And this is years. All right. So the variable we're going to be solving for is there, which is an exponent. That's why we do logarithms. So let's put it all together and we'll kind of see how that works. Okay, so used car price we know is $20,000, right? All right, new car price we know is $24,000. The rate, they told us the rate is 8%, so that's 0.08. I wrote it as a decimal. And then the time is T. I don't know what T is, so I just leave it as T. So that's the base equation. Now, what I like to do in these problems, I like to collapse it as much as I can possibly collapse it before moving on. Okay, and I also like to put a little symbol there to remind myself that I'm multiplying. So the next step, the first thing I would do is collapse these 2 pieces together. So 20,000 equals 24,000 times 1, 1 minus 0.08 is what? 0.92 raised to the T. Okay? And I also put that there to remind myself that they're being multiplied. The next thing I like to do is get rid of this 24,000. I like to divide by 24,000 on both sides. Because if I divide by 24,000 on both sides, I know that these will cancel out. If those cancel out, now I'm in a good shape because I'm really looking at something like Well, these are gone. So I have 0.92 raised to the t power equals whatever this is divided. It's some kind of decimal. I'll figure out what that is. Let me see. That's going to be 20 divided by 24. Oops. 20 divided by 24. It's going to be 0.833. Okay? So we got down to this point, and now we're stuck. There's nowhere you can go from this point. And if you didn't know how to do logarithms from earlier, you can't do anything from this point. So, but we did just do logarithms, and we know how it's set up. So now we can convert back and actually solve this problem. So let's do the color scheme again. I wish I could, but I can't. Just like I could do this. Hold on. I'll show you how we can make this work. Got that guy, down here, this guy. Perfect. Okay, so here's our key from the previous lesson idea, right? So let's do some highlighting of the colors here. So the yellow is going to be this guy. Now notice it's kind of flipped. It's flipped around the equal sign, but it doesn't matter. It's still the same stripe. All right, the green, this green right here is going to be this guy right here. Okay, and my blue, which is that guy right there, is going to be this T. Okay, so I have my colors all kind of organized the same route. Now what I'm going to do is I'm going to convert back to this log. So the log, right, well, it says green goes low. So green goes low, which is 0.92. That goes low. And then it says yellow goes on the same line. So that's 0.833. And then the blue goes on the other side, which is T. All right, perfect. It's actually done, believe it or not. This is done. All we have to do is turn this into the calculator. So calculator, right? And we know in the calculator you're going to go log on the top and a log on the bottom, right? Well, on the top, you keep the 0.833. On the bottom, you point to 0.92. And that's going to give you your answer for T, which is what we want. So that goes in the calculator. And you should know how to do that if you watched the first part of the video. So log 0.833, close it, divided by log. And you got to close that parenthesis. If you don't close that parenthesis, you get the wrong answer. 0.92, close it. I get 2.19 years. 2.19 years. There you go. So what you guys got? Perfect. And that's it. So the reason we need to know how to do logarithms is to be able to solve problems like that. Does that make sense? I know it was a lot, like a whole extra lesson just to be able to do that, but that's an important skill. And actually, really, you're getting a discount anyway. You're getting a quarter's worth of algebra 2 in one day. Actually, in just under a half hour. How about that? Okay, so that's it for the video. We're going to do some more practice problems, but you guys need to finish up the rest of that sheet on your own, and we'll talk about that later. So.